Alright, so this is the Predicting Products Volume 1, because in this video, we're only going to look at simple binary composition and decomposition, and we'll also take a look at combustion. Okay, so when I ask for you to predict products, remember our reactants are what we start with on the left-hand side of the yield arrow. I'm asking for what the products would be. So this requires us to understand reaction types and look for patterns about how things rearrange themselves in a chemical equation. Okay, so before we dive into some examples, let's just make sure we are familiar with what these three types of reaction types look like. What types of reaction types? So, if we look at these are complete reactions. So we see we have the reactants on the left-hand side and the products on the right-hand side. If it's a composition reaction, we know that it's going to be multiple reactants forming one product. Okay, and again, we are only going to focus on binary, meaning we're only going to focus on two elements coming together. Same thing with decomposition. Decomposition, we're starting with one reactant breaking down into multiple products. Okay, and again, we're only looking at simple binary ones. They can get a lot more complicated. All of this, imagine that. Chemistry can get a lot more complicated. But for right now, we're just starting with the basics. And then finally, combustion. A lot of you have been able to identify combustion reactions based on these two products here, CO2 and H2O, which is good. You already know what the products are of these combustions. But I also need for you to identify that these are combustion based on the reactants. So if I were to give you the reactants, a hydrocarbon, for example, plus oxygen, so something burning in the presence of oxygen, that would yield the products that you are very familiar with, okay? So let's just look at what some of these problems look like. Okay, so I see here, I'm given the reactants. I am asked to predict the products based on how things typically behave in the reaction types, okay? And each of the types has different rules. So for composition, okay, it is so important that you ignore whatever subscripts are here. Do not allow for those to dictate what product you are going to form. Instead, we are more concerned with the charges of each of the individual elements, okay? And when I say charges, again, so in this first one, it requires you to know the charges of each of the groups. So magnesium has a positive 2 charge and it becomes an ion. Chlorine, a negative 1 charge. So when I say ignore subscripts and crisscross charges, I'm talking about these up here. So what group they're in and how many valence electrons they have will tell us the charge. So, magnesium, positive 2 charge. Chlorine, I am ignoring this subscript. Instead, I am more concerned with chlorine's charge, a negative 1. This is basically an ionic compound. It's a metal wanting to come together with a nonmetal. So we will crisscross those charges. When I do that, I form the product NgCl2. Okay, so this was not formed because I just smushed these together. It was formed because I crisscrossed the charges, and we need 2 chlorines for every 1 magnesium in order to balance out the charges. Okay, so now let's look at a decomposition. Decomposition, one reactant, we got to break it down into multiple products. And because we're doing really simple ones, we're just breaking it down into its individual elements. Okay, again, we are ignoring subscripts, only concerned with the elements that are there. For decomposition, this requires me to know about something called diatomic molecules. Di meaning 2, atom. Diatomic molecules are molecules that have 2 atoms of the same element. Okay, so these are elements that can exist by themselves as singular atoms. Okay, when they're a part of other compounds, it's fine, but when they're by themselves, they always show up in pairs. Okay, that is 7-Up. 3 reasons it's called 7-Up. 1, it looks like a 7-Up, like quite literally. The second reason, it starts with element number 7, nitrogen. The third reason is called 7-Up. 1, 2, 3, 4, 5, 6, 7 total. You do have to memorize those, so make sure you color them in on your periodic table so that you're used to looking at them over and over, okay? So I have to keep a red flag out for these, because if I break down a compound and one of these is by itself, it has to have 2 as a subscript. So let's look here. Again, ignore your subscripts in the reactants part. Split it apart into its 2 parts. We have K plus O. The only subscripts I add on the product side are 2's if they're diatomic. K, not one of 7 up. Oxygen is a diatomic. I will add a subscript 2. And you are done. People want to make those a lot harder than they are, but those are some of the easiest. Split it apart, only add a 2 if necessary. Okay? So now, down here, combustion. We see a hydrocarbon plus O2. It doesn't even matter what these subscripts are. My product, CO2 and H2O. Doesn't matter. Now, the one thing to note is that none of these have been balanced yet. But right now, for this video, we are just focusing on determining the correct products, because if you don't get the products right, it doesn't matter if you can balance. So here on the right-hand, or on the left-hand side, excuse me, there is one thing that hopefully will help you remember. Composition starts with a C. Composition, crisscross. Composition, crisscross. Composition, crisscross. Decomposition, D, diatomic. Decomposition, diatomic. Decomposition, diatomic. Okay? So let's look at some more examples. And again, you can pause the video, try them yourself. When we come back, we will have them solved. Okay, so for this one, I know it's composition, 2 individual elements. We're wanting for these to come together to form one product. So because it's composition, I'm going to crisscross charges. Ignoring the subscript, only looking at charges. So we have calcium. Calcium, positive 2 charge. Nitrogen, again, do not care about this 2. Nitrogen, negative 3. Crisscross charges. My product, Ca3N2. And you're done with that one. So now, let's look at the next one. Decomposition. I can tell it's decomposition because it's one reactant. So, ignore the subscripts. 2 and the 3, forget about them. But you're going to break them down into their individual elements. Al plus O. Notice I didn't write Al2 plus O3 because you're ignoring the subscripts, my sweet children. So now, based on the 2 things you've written, you need to look and see if there are any diatomic molecules here. Aluminum, it is not part of 7-Up. Leave it alone. Oxygen, however, is one of the 7. It is a diatomic. It needs a 2. You're done. At the bottom, I can identify this as combustion. We have a hydrocarbon. We have oxygen. Easy peasy lemon squeezy. CO2 plus H2O. Again, your final step would be balancing, but we will save that for another video.